Hello, hello. Welcome to the HelloStavanger diversity training. In this session, you will learn to respect other people with different software choices, appreciate the differences in the tools we use, and also recognize that when we are using different things, we go stronger together. Let's have fun. Why should we care about diversity? Well, the reason why we should care about diversity is that the opposite actually has some fairly bad negative consequences, at least some of the time. I'll give you an example. July 19th, last year, there was an update to IDS software called Crowdstrike that sort of struck, and it ended up with having airports being shut down. Something like 5% of all the air travel in the world was cancelled that day. Banks were impacted, payment systems went down, gas stations wouldn't fill your petrol tank, emergency phone services were not working in some places, surgeries were postponed and stopped in some places. Basically, as an outage, it was fairly bad. But what made it bad? Like, the proximate problem, yeah, there was an update to Crowdstrike, we all know the story, and that somehow ended up in the kernel of Windows and made the computers not boot and not work. But the real problem here is that all of these things, like entire airports, were completely dependent on a single combination of an operating system, Windows in this case, and an IDS, Crowdstrike. If, say, half of the check-in machines had used some other combination, check-in would have been open that day in most of these airports. Yeah, you would have had longer queues, but that's fine. So, considering which situation would you rather find yourself in? Is it the one where the entire thing is shut down, nothing's working? Or is it, as happened with the same outage in a local shop somewhere in New Zealand, apparently, that they had slightly longer queues? My contention is that the slightly longer queues is sort of the better way of handling global IT outage. And this isn't isolated either. Actually, it seems to be getting worse. Malware, cryptoworm type of attacks that were all the rage a few years ago had sort of the same thing. Say, WannaCry was entirely reliant on unpatched Windows machines. Up-to-date Windows machines were not vulnerable to WannaCry, but it had to be only a certain version. And for some reason, in the NHS, UK's health services, 70,000 devices ran that unupdated Windows version. And they were all impacted, and hospitals shut down, basically. Ambulances were diverted, and it was not a good few days. Again, what's the problem having a non-updated Windows version running in production? It's not a good thing when it's connected to the internet, but another way to look at it, again, is that there was too many things reliant on that one. If they also had, say, BSD boxes that they could just swap in or something, problem would be solved in a minute, or however long it takes to boot BSD these days. And we saw this again this Monday. This week, this happened. US East 1, a DNS was apparently misconfigured, and Snapchat, Reddit, Lloyds, Roblox, Fortnite. Actually, we could probably do without some of these, but they were all down. Half the internet, gone, because of a single line in DNS. And we can speculate as to why this happened, but I don't think that's the point. And DNS is sort of, and its precursors, it was designed to withstand nuclear war. It was designed to withstand network segmentation. So these are things that actually could have worked very, very well, even if a single point goes down. except somebody actually introduced a single point of failure in USDs 1 here for the Dynamo DB apparently, which is not good. So what we're talking about here are these sort of black swan events. Fairly rare occurrences that have really outsized impacts, and impacts even globally in many places. Hi, I'm Inge. I've been working in software engineering in about 20 years. I did my master's in security, so I have some credentials in this field as well. And I'm working as a consultant now with my employer, T8 Library, who likes that I say that. So how are these sort of problems solved outside IT? So diversity is, for instance, in biological systems, quite crucial. We know that ecosystems that are more diverse are more resilient. This has been studied very, very thoroughly. And one of the reasons is that illnesses, viruses and such, don't transmit as well between species as inside species. So it's very unlikely for a single occurrence to affect the entire ecosystem when there is diversity in the ecosystem. That is, there are nodes that handle different things in that system, or animals. It's also better for agriculture and productivity in the ecosystem as well. Another thing, in our organizations, we also use diversity. For organization, diversity is assumed at least to be better for decision-making, engagement, innovation, productivity, creativity, reputation, cultural benefits. Basically, it's great. And even in software tools, we have a lot of diversity. So there is this guy who has collected a list of 154, probably more by now, text editors that are all open source and on his GitHub. Why that has been done, I am not sure, but it's sort of great that it's being done, because when we have all these different tools that do almost the same thing, they can innovate, they can try, they can experiment, and they can even break, and it doesn't really do anything, because there's so much other choice. And also, we are able to get something that fits our specific context, almost, quite well. And we also see the same in Unix variations, all these Linux distros popping up in and out of existence and all of that. So we have the diversity in the open source system. But what does this look like more in our system? How do we create a system that is diverse? Two ways to look at it. Williams et al. In the wonderful article, Security Through Diversity, from which I did not steal the title for this talk. They divide diversity into sort of design diversity and data diversity. And I'll go through those together. Hole, in his anti-fragile ICT systems, sort of cobbles them together in a more systems thinking diversity thing. So he's more about the diversity of the system itself. Design diversity, this is where you recognize that any system may be flawed, however well designed it is, and however well implemented it is. And what you do is you use parallel approaches to combat this. This is popular in physical engineering. Say, think of an elevator. If the elevator cable snaps, and it's a fairly modern elevator and you're lucky, you won't drop to the ground. You'll actually stop because there are brakes on the elevators. And if those brakes don't work, there's another system that should at least mitigate the situation somewhat. Airbags or whatnot. So we do use these for fail-safes all the time in physical engineering. And I'm thinking they should probably be used also in software engineering. In software, it might look like you running the same piece of software, but on different platforms. Now at least it runs slightly differently. The platform is different, so it has different starting and endpoint, and it's not susceptible to all the same problems. It's susceptible to different problems, but not necessarily the same ones. And you can also use different software that do almost the same thing. And this way, you can protect fairly well against sort of design flaws in your system. Whenever you figure out there's a design flaw in one of your systems, you just use the ones that are not susceptible to that flaw. And it also protects well against these rare swan type events that you can just not throw out what's not working and what can be used right now and just use whatever's possible to use. Real drawback here is you actually increase your attack surface because you have different systems doing the same thing. And yeah, there's a give and take there. With data diversity, the software itself stays the same, but you vary its data in some sense. What you might vary is how the data is laid out in memory. You might do some reordering of the instructions on machine level instructions, so it does the same thing, but it does it differently. And thus, if there's a buffer overflow in one, it will probably not happen in the other. Or you do more automatically through some address space layout randomization. Shout out to OpenBSD for inventing that. And this has an advantage that it protects well against many vulnerabilities, especially these sort of memory-based attacks that happen. And you don't really increase the attack surface much. You might even reduce it a bit. The disadvantage is that rare systemic flaws may not be as impacted by this. Malware attacks will probably be impacted, but other flaws may not. And vulnerabilities in systems that you have run through these kind of processes are not necessarily less vulnerable. The vulnerabilities still exist. It's just really, really, really much more harder to exploit them. And there do actually exist these de-randomization attacks on these kind of things, very complex. Huda's idea is that diversity happens when two or more components do more or less the same thing, but are implemented somewhat differently, which sort of encompasses both design and data and diversity. The idea here is that redundancy, that's great. We all like redundancy. We're not running our big websites on one computer because that might crash at any moment. We're running it on 2 or 3 or more. And this is great, except that redundancy and diversity is even better. Say we have our website running on free servers with different web servers, HTTP, implementations and something like that. Now, if that part also is not usable, one of them, the others will be. And this is taken from the book Anti-Fragile ICT Systems by Ole. And his idea is that in order to create a truly anti-fragile, so a system that gets stronger even with flaws or with bad events happening to it, you need these 4 types of properties in your system: modularity, weak links, redundancy, and of course diversity. Which I think is slightly more forgotten than the other ones from time to time. And this is because we do get some fragility when there is a lack of diversity. local errors can jump sometimes between modules in monocultures. But this is much harder to do when you have a diverse set. So in a network, if all the machines are the same, a worm in one of them may spread to all of them. If you make sure that your network topology does not let every machine contact everybody else, but only contact different machines, like the circles, at least two of the circles there, then they can't jump anywhere. And if it's compacted into clusters, you can just jump into your own cluster, and vulnerability spreading or exploit spreading might stop there. And this actually works against malwares because malwares tend to be reliant on a small set of vulnerabilities. It's not just one anymore, but it's a small set. So if you have more than two, say 5 different systems and compact them and segment them, this might help. So let's look at it at a slightly bigger scale. Let's play some what-ifs. What if the dominating desktop operating system can no longer be trusted or used for whatever reason? And the dominating desktop operating system is, of course, Microsoft's Windows. It's great. It has over 70% market share. It's fairly stable, seems to be slightly declining, but not much. If that happened, governments, militaries, and corporations would basically not have desktop computers anymore because of this enormous market share. What we would have is like a few MacBooks here and there, nice, and some minor players, including open source operating systems all over the place, but those are in such an extreme minority that this would actually be bad. But who cares about desktops? We're all using web anyway. We could just buy Chromebooks or something and it will all be fine. So what happened if the software as a service major vendors for like productivity type software can no longer be trusted? Here we have a slightly different picture. Here we have a duopoly. Microsoft and Google share somewhere between 70 and 99% of the market, depending on which statistic you use. And they're both US-based, so they might even become untrusted at the same time. So if one of them becomes trusted, yes, we can probably all switch to the other. Good. Now we have a monopoly situation. Not good. But if both cannot be trusted, what do we have left? We have things running locally. Nobody's really using that anymore, and we don't really know where our files are stored, so that might be a problem. There are other popular options, LibreOffice, but that doesn't really show up in the graphs here. Or we could create new applications. That might actually be our best bet. There are cloud services from European vendors that do provide these sort of offerings, but my contention there is that right now we're not ready because we're not using them. And if we all shift load to them, that would be a problem for them, actually. But who cares about this? Applications are not that important. It's the data that's important. It's where we run our applications, where we run the data, store our data, the cloud. So here the picture is even better. Now we have a triopoly. There's 3 large vendors in Europe, except European cloud vendors are like 15% and declining, which might not be good for us around here, but at least if AWS disappears and cannot be used, say US East 1 goes down for a day, then Azure and GCP can probably take at least most of that load. our 15% of European vendors could never take that load. There's just not capacity. So we might be in trouble, people. This must be fixed. Okay, on the society scale, fine, diversity might be good, but what does it do for my application, my security concerns? And when analyzing security, it's sometimes fun to use this CIA triad. When I went to school, we also had non-repudiation in this group, but that has somehow disappeared. I don't think anybody understood what it really meant anyway, so that's fine. And it's probably not useful for diversity. But for confidentiality, we can, with diversity, spread data across different platforms, segment on sensitivity and those kinds of things. That might be nice. Now we can have our really sensitive data on our HPUX or OpenBSD boxes, and our not that sensitive data running on our Windows servers, and the in-between running on our Linux servers or something. And that could be a nice way to go. Of course, this does increase the attack surface. So if it's a problem that one of these places are compromised, might be a problem. What you could also do is spread data so that you need all the platforms to be compromised at the same time in order to get anything useful out of it. Then it's probably a lot more difficult to use the system, but depending on how you want. For integrity, data can be replicated across different platforms as well. Now confidentiality goes out the window, but integrity becomes very strong. And we saw this way back in the day with disk RAIDs. We had a problem with monoculture that RAID vendors would recommend that we use the same hard drive for all disks in the RAID. This meant that hard drives ordered simultaneously, so from the same production batch usually, were put in RAIDs, got the exact same usage, and of course failed at the exact same time. And data was lost. It was terrible. So adding some diversity in the hard drives vendors was actually useful and helped. Availability is the sort of place where I think diversity really shines, really adds value. Now, when there's an outage in one platform, if you have replicated your data at least, then that doesn't necessarily impact your system at all, or only degrades it to some lower point, but still working. Think of the airport machines that half of them are still up. Yeah, you're degraded, but you're okay. And also there are all kinds of DOS vulnerabilities and stuff that are often platform-specific or application-specific in some case. So, how do we diversify our software? One way, on a sort of organizational level, let people use the right tools for them. Many organizations like to constrict the tools and software that's available to employees. There are really good reasons for this, don't get me wrong, but there are also some dangers here in that if some of these tools cannot be used suddenly, you're in trouble. Now you have no tools, you have no backup. By letting people use all the tools that you want, you get a very diverse set of tools. Of course, managing this might be a bit of an administrative nightmare, so the best way to go is perhaps something in the middle. On a single application, there are these things called diversity engines that I find incredibly interesting. They allow you to change a program that's compiled or written imperceptibly, so it has the same functionality, that's sort of forgiven, but it works differently. It does different things, or does things in slightly different orders. So you move to before or after the add, or those kinds of things, so that they become different. And this even works for interpreted code. So there are JavaScript diversity engines that do reorderings and stuff just to make sure that you have different vulnerabilities in different versions. Another way to go could be to do model-based software engineering, where you create your software in some sort of very high-level model. Doesn't have to be this one. And from that, you derive your implementations. Now it becomes very cheap to derive new implementations. This reduces, this will actually introduce design diversity, because you have very different implementations. They can be for completely different platforms, soft languages, and so forth. And this works. And bonus, here you can even sometimes, at least, verify the models mathematically, so you actually know the software will work in the end for all the platforms, but given that the transformer works. Final way to go could be by standardizing platforms and data APIs. Say, when you run a piece of code, you want to be able to create it so that it can at least run on several different platforms. Build your containers so they can be run in BSD-GLs as well as in Kubernetes and in Docker swarms, which OCI containers do. Hey, yeah. Make sure that your infrastructure is modeled so you can recreate it if you cannot use it again, and so forth. And speaking of standardizing data, web is a great thing, right? The web standardizes how we run applications. It does so by creating these browsers where we have JavaScript engines that do almost the same thing across all the browsers. And now we are able to create this explosion of application creations. Right? There's millions, billions, perhaps, web applications out there. It's a mess, but it's a very diverse mess. Problem is that each of these applications have only one data source usually. It's the one they're hard-coded to use. Very often from the same vendor as the one who created the web application code. So if you're using Office 365, Office 365 fetches data from Microsoft's things. A solution to this might be Solid, which standardizes how data is stored and accessed. So with Solid, which is an open standard for structuring data and digital identities on web, you will be able to have your application actually talk to different data stores called pods, which is where data is stored in Solid, and have the same application can read data for all users and only access one at a time. So the application in itself doesn't need a backend in many cases. Whereas each data cannot even be accessed by many applications. So you get diversity for your actual application, which is great for diversity, right? So, summing up, diversity is a good thing, even for software. And I believe that it's probably better that some things fail fairly often than that all the things fail sometimes. Because that's not fun. Also, don't assume, please, that what works today works forever, and watch out for black swans, because they do really exist. Apparently in Australia somewhere. Thank you.